to the NetApp on NetApp video series. My name is Scott Stanford with NetApp IT, and today we're going to be talking about Spot Ocean. What is Spot Ocean? Ocean helps reduce the cost of the worker nodes running in hyperscaler-based Kubernetes clusters. The clusters can be self-managed, running on instances that are not managed through the hyperscaler Kubernetes service, or they can be clusters that are native to the hyperscaler like EKS or ECS. Ocean manages the worker nodes in the Kubernetes clusters. In the past, you might have needed to create automation to handle scale up and scale down on the cluster. Ocean handles that automatically for you. The most savings with Spot Ocean is by using Spot instances within the cluster. Though it is possible to use on-demand instances or any combination of Spot and on-demand. And with that, you can have most of your worker nodes be, let's say, Spot instances, and then you can have a separate group of machines that are on-demand instances that could run like databases or anything that's in your cluster that can't handle any type of interruption or limited interruption. For AWS, when using Spot instances, there's a 2-minute warning that you can receive before the instance is replaced by AWS. It also leaves the consumer to manage the EBS volumes and the ENIs and any data associated with that. Ocean handles that for you. It manages the EBS volumes and ENIs so you can preserve your IP between Spot instances. You can retain your data that's saved on the disk at the time that the Spot instance is shut down and have that when the new instance is launched. Ocean also has predictive replacements, where it uses machine learning to predict when a Spot instance is likely to be replaced and will preemptively replace that instance 15 minutes ahead of time, allowing for longer draining times of your networker nodes. Updating the worker nodes in the cluster is very easy through cluster roles. The cluster role will replace the worker nodes using a blue-green methodology with user-defined batch sizes. So let's say you want to go through and update your AMI, or you want to make a setting on change on the instance types or security groups that are used. You would update those settings in your cluster in Ocean, and then you do a cluster role, which would then walk through your cluster and replace the nodes. It would cord and drain each of the nodes and then replace those with new instances. Regardless of whether you're using Spot instances or on-demand, Ocean will bin pack the cluster to reduce waste. So let's say you have 100 CPUs worth of pods running in the cluster, but your worker nodes have a total of 150 CPUs. Ocean will go through and try to reduce your worker nodes to match your pod usage. So it'll try to get as close as it can to that 100 CPU within the cluster to reduce the waste. And it's like one big Tetris game where it'll use different instance sizes and types to kind of get down to that right size to reduce that waste. It also has a concept of headroom to reduce the deployment times of anything new in your cluster so that there's spare CPU and memory in your cluster so you don't have to wait for new instances to be launched when there's a demand in the cluster. And it's completely user configurable, both at a cluster and at a node group level. So here's a cluster that we have that we're just using for testing some things out. Before I do anything, I want to go through and start a cluster role. So these are the nodes that are running in the cluster, and you can see it's a different set of instance types that are used. Some are the same, some are different. And Ocean's going through and just trying to figure out the right combination to use to have the most efficiency. So I'm going to kick off a cluster role, and I'm going to batch size of 20. I think there's about 10 nodes in the cluster, so it should do about two at a time. Yeah, so it's going to go through and replace 2 nodes at a time. It will cord and drain 2 nodes while it adds new nodes to replace it. It may not use, if it's replacing 2 nodes, it may replace it with more than 2 nodes or less, or 2 nodes, depending on the instance types that are used. It'll have that same capacity within the cluster. So we'll check back on that in a couple minutes. So this is the overview page. You can see the number of nodes in the cluster, how many pods are running. Yeah, for this month, this is what the savings we have in this cluster. So almost 58% savings in the cluster. Because we're in this cluster, it's 100% spot, so we're getting a fair amount of savings. These two graphs, you can see the headroom. On the left is the CPU, and on the right is the memory. So we definitely have more headroom for CPU than we do memory, just because our workloads are more CPU-centric than memory. We look down here, I'm going to expand this to a day. So you can see this is what I was talking about, the scale up and scale down within the cluster. Ocean's going through and managing it for you. And you can see different times where there's been almost 20 nodes in the cluster down to around 3. And those are just different sizes of the nodes in the cluster. I'm going to change this to a day so you can see the pod activity. So part of it is related to the pod activity. You can see there's a lull here, which matches this. But that doesn't mean that it doesn't handle that capacity. So this chart is just showing that the nodes, it doesn't take into account the instance types or sizes. So they could be larger instances, just fewer, or there could be more instances that are smaller. But it's very dynamic and it handles all these scale up for you. And you can see where the scale ups and replacements are occurring. One of the nice things with Ocean is you can see the cost analysis by namespace or labels. You can set this here. What we're looking at is at a namespace level. So on a daily basis, you can see what each namespace is incurring as far as cost goes. You can change it to month or hour if you're interested. Another nice feature about Ocean is the right sizing. Most companies, definitely us, we have issues with over provisioning. You can see on the left, this bottom line is how much CPU is being used versus what's being requested. And the same thing on the right for the memory. So we definitely have a bunch of over provisioning happening in the cluster that if we were able to reduce that, then we would also save on cost as well. And Ocean also makes recommendations on what those requests should be based on what it's seen running in the cluster. So you could go through and expand these. So here, this deployment's using the pod's using half CPU, and it's recommending about 1/10 of a CPU along with a memory change. So you can dig through here and see the different recommendations. They really do vary. The impact is based on how much difference there is between what's being consumed and what's being requested. You can also see the namespaces, pods, and services, which are same as you can see at the command line with kubectl. You can have multiple virtual node groups. So the virtual node groups are really just a collection or a definition of what to use for compute. So in this case, we have this one virtual node group, which is being used for most of our instances. It's a default one that doesn't have any taints or labels, or doesn't have any taints on it. You specify the AMI. If we go through and we look at the actual JSON for it, we can see the instance sizes that we have listed for it or defined for it, the labels. Also that we can define the headroom at a virtual node group and the different sizes you can have in there. In this case, it's 100% spot. And if we look back in the actual wizard for it, you can see it's a minimum of 2 nodes, maximum of 100% spot. And we have 2 CPUs and roughly 4 gig of memory that's reserved for headroom within the cluster. You can also have, as speaking earlier, where you might need to have like on-demand instances. This node group is very similar to one we just looked at, except it has some taints on it. So only when you have a node selector and taint with using on-demand will you execute on this virtual node group. Otherwise, it's near identical to the other one. And you can see here there are no running pods, no nodes on that virtual node group. If we were to launch a replica set using that taint, a replica set of 3, for example, what Ocean would do is not just spin up one worker node out of this virtual node group, it would spin up enough to handle the replicas and any anti-infinity that is part of that deployment. Quick look over at the nodes. If some of these have been replaced. And that's a little hard to tell in this view. But if we look at the cluster role, we should be through the first batch. So we've already had some nodes replaced. Again, the nodes were cored and drained while new nodes were added. The existing nodes were not removed from the cluster until the new nodes were up and running in the cluster. And it's completely automatic, and Ocean will work through all the nodes in the cluster. If it fails, it just won't replace those nodes, and it'll cancel the cluster role. And that is Spot Ocean. Thank you.